A couple more questions from the Technicon on integration by parts. As you can see, that is not a very difficult technique that we use when we're integrating. The key is just to make sure you pick your U and dv correctly, so that whatever it is you're integrating, you'll be able to do so without any problems. So we look at question 21. This is the integral of x times a to the power of x dx. So we say you need to pick your u as well as your dv, and whenever you have a polynomial like this, you always want to pick that as the one that you will differentiate, because eventually the derivative goes to 0. So we say u is equal to x, and then our dv is a to the power of x dx. And we know integrating a to the power of x is not that difficult to do. So differentiate, we have du is equal to dx, and then here v, the integral of a to the power of x is a to the power of x divided by ln of a. So now we have our four terms. We know the integral of x, a to the power of x dx. This is u times v, so x times a to the power of x over ln of x. So we have x, a to the power of x over ln of x, and then we subtract the integral of v multiplied by du. That's a to the power of x over ln of a, and du is just dx. Okay, ln of a is a constant, so it can go outside, and then we integrate a to the power of x, which is a to the power of x over ln of a. So this integral will give us x, a to the power of x. Why do I have ln of x here? This should be a. So we have ln of a minus a to the power of x over ln of a squared, and then you add your constant of integration. Okay, that's 21. And number 22. We have the integral of x log base a of x dx. So with these questions, when the base of your logarithm is not e, what you should do is rewrite the logarithm so that the base is e. And we say to do that, this is just ln of x divided by ln of a, and we know that ln of a is a constant, and you can always take it out. So integrating x log base a of x is the same as integrating x ln of x over ln of a dx. Okay, so now this we say we can take out, and then you just need to pick your u and dv. So here we say normally we would pick this as our u, and then whatever is it's multiplying by will be our dv. But in this case, if we say we are going to integrate ln of x, we will have to use integration by part. So it's best if we pick u as ln of x. So u is equal to ln of x, and then dv is equal to x dx. Then differentiate, we have du is 1 over x dx, And then v is x squared over 2. Now we have our 4 terms. We can work out the integral. So here we have 1 over ln of a. We take it outside. The x ln of x dx. This is 1 over ln of a multiplied by u times v. So we have x squared over 2 ln of x, and then minus the integral of v times du. So minus the integral of v is x squared over 2, and du is 1 over x dx. And then we close our bracket here. Like that. Okay, this gives us one over ln of a and x squared over 2 ln of x minus the integral of x over 2 dx, which is 1 over ln of a x squared over 2 ln of x, and then the integral of x over 2 is x squared over 4. And then we can close our bracket and then add our constant of integration. So you can multiply everything in and then change this back to log base a if you like. So this is x squared over 2 log base a of x minus x squared over 4 ln of a. Then we have our c over there. Number 23, we have a definite integral from 0 to 1 of sine inverse of x dx. So with this one here, again, pick your u and dv. So our u is equal to sine inverse of x, then our dv is going to be equal to dx. Differentiate, we have du 1 over the square root of 1 minus x squared dx, and v is equal to x. So we have our 4 terms here. Just substitute them into the formula. Okay, so I'm going to work out the indefinite integral first, and then once I have the answer, then I will substitute. So dx, this is uv, so x sine inverse of x, then minus the integral of v du, which is x over the square root of 1 minus x squared dx. Okay, so this gives us x sine inverse of x, and this one over here, to integrate it, we can see that the derivative of the denominator is minus 2x, so this minus can go there, and we need a 2 here and a half outside. So what we need is this. So the plus and then minus 2 there, a half over there, so that the numerator is now the derivative of the denominator there, and then we can just look at this as u to the power of minus a half. The integral of that is just 2u to the power of a half, and then the 2 that we get from integrating this will cancel with the half there. So our integral is just the square root of 1 minus a half squared. Okay, so with the indefinite integral, we would have the constant there, but the question said we need the definite integral from 0 to 1. So now we work it out. This is x sine inverse of x plus square root of 1 minus x squared from 0 to 1. So substituting, we have 1 sine inverse of 1. So this is sine inverse of 1 plus 1 minus 1 squared. This is 0. So this is our first term. And then for the second one, when we substitute 0, this is 0, and then 1 minus 0 is just the square root of 1, which is 1. So I don't even need these brackets here. So sine inverse of 1 minus 1, this will give us pi over 2 minus 1. So calculator is in radians here. Number 28. Integral of inverse of x dx. So this one we would do in pretty much the same way as we did the previous one. We pick our u. U is the hyperbolic tan inverse of x, and dv is just dx. We differentiate the hyperbolic tan, get 1 over 1 minus x squared dx, and v is equal to x. So now our integral of the hyperbolic tan inverse of x dx, this is u times v, x tan hyperbolic inverse of x, and then we subtract the product of v and du, which is x over 1 minus x squared dx. Okay, so here the numerator can be written as the derivative of the numerator. So this minus here will go there. We need a 2 here and a half outside. So doing that, say we need a minus 2 here, and that means we need a plus a half outside. So our integral then becomes x hyperbolic inverse of x, then plus a half. The integral of this term here is now just 1 plus x squared. No, it's now just ln of this. because the power here is -1, so it's ln of this. So it's half ln of 1 minus x squared, and then we add our constant of integration. And we can look at one more, number 29. We have the integral of sec cubed of x dx. So with this one here, it might be useful before we integrate to rewrite it using some of our trigonometric identities. So we can see sec to the power of 3 of x as the integral of sec squared x times sec x dx. And then this one here, we write it as tan squared plus 1. So this will be the integral of tan squared x plus 1 times sec x dx. Okay, then multiplying out, we have the integral of sec x tan squared of x plus sec x dx. And we can split it up because we know what the integral of sec x is. It's just ln of sec x plus tan x. And then here we can use by parts. So we will pick our u to be equal to tan x, and then pick dv to be equal to sec x tan x, because we know how to integrate that one, and that means that dv is equal to sec squared x dx, and here v is equal to sec x, like that. Okay, so this integration by parts is the integral of this one. So now what we have is the integral, not the integral, it's just uv. Okay, so we've split up the integral here. So this part here, the integral is u times v. So that's sec x tan x and then minus the integral of v times du. So it's sec x times sec cubed times sec squared of x, which is sec cubed of x dx. And then the integral of sec x, we said, is ln of sec x plus tan x. Okay, now here you can see I have a sec cubed of x again, and on the right hand side I have sec cubed of x. So that negative sec cubed, I can take it to the other side. So when you're writing on paper and you have a clear left hand side and right hand side, it's easier to see. So we have 2 integral of sec cubed of x dx. This is sec x tan x plus ln of sec x plus tan x, and then we divide everything by 2, and that means that the integral of sec cubed x dx, this is a half sec x tan x plus ln of sec x plus tan x. and then you add the constant of integration. Okay, so sometimes you will have to simplify what it is you are given before you use integration by parts. But I think sec cubed, if you maybe saw it as sec squared times sec x, I don't know if that would be easier to integrate, saying u is sec, I don't know, you can try that one and see if that is easier to integrate without changing it and rewriting it in terms of tan. And then that brings us to our topic for today, which is integration by means of partial fractions. Integration Okay, so last semester we already learned about partial fractions and how to decompose a fraction that you're given into its partial fractions. So I'm not even going to go excuse me, into details of how we would do that. So you should know how to break down a fraction into its partial fractions. There are 3 or 4 types that we look at. The first one is when your numerator has a higher degree than the denominator. First thing you must do is use long division and rewrite it so that you have a denominator with a higher degree than the numerator, and then you would then use partial fractions again, decompose that one. Then the second one is when you have linear factors. Linear repeated factors is the third one, quadratic factors and quadratic repeated factors. So all of those you should remember. If not, go and find your notes from last semester and and revise. So we'll just look at the exercises. So questions from exercise 4.3. So I've picked them at random. We start with number 19. Number 19, we have to integrate x to the power of 3 minus 3x squared plus x minus 1 over x squared minus 4x plus 4 dx. Okay, so we want to integrate this. Obviously, you can you may think, okay, can I not make the derivative here? No, you cannot. Okay, so what you should do is you should decompose this into its partial fractions. But before you do that, you look at the numerator. The degree is 3, the denominator, the degree is 2. So before you start decomposing, you must use long division. So long division, we have x squared minus 4x plus 4 and then x cubed minus 3x squared plus x minus 1. Then we divide the way we always do, x cubed divided by x squared. This is x, and then you multiply, get x to the power of 3 minus 4x squared plus 4x. And then you subtract. This is 0. Negative 3 minus negative 4 is positive x squared. And then 1 minus 4 is -3. And then -1 comes down. Then the degree here is equal to the degree that we have there, so we must continue. So x squared divided by x squared, this is 1. And then we multiply x squared times 1, this is x squared. And then -4x times 1, that's -4x. And then 4 times 1 is 4. And then subtract, as always, x squared minus x squared is 0. -3 minus -4, this is just x. And then -1 minus 4 is -5. Okay, now the degree here is less than the degree we have there, so we can stop and rewrite this like this. So we have the integral, instead of that big fraction, what we have is x plus 1 plus x minus 5 over x squared minus 4x plus 4 dx. Okay, so this part x plus 1 we can easily integrate it without any problems. The problem is this one over here. So integrating this one over here, what we would do, or what we can do, is we factorize the denominator. So this is the integral of x plus 1 and x minus 5 over x minus 2 squared dx. Okay, so this is the one that we want to decompose into its partial fractions. So here we have a linear factor, but it is repeated. So we have x minus 5 over x minus 2 squared. We'd write this as a over x minus 2 plus b over x minus 2 squared. Then we would combine these two. So you have a is x minus 2 plus b is equal to the numerator that you have here, which is x minus 5. Or yeah, you would do it like that. And then you can say when x is 2, so if x is equal to 2, then this is 0, and you have b is equal to 2 minus 5, which is minus 3. And then you can say when x is 1, for example, not 1, let's make it 3. When x is 3, for example, you would have a plus b. b is -3. And then on the other side, we have 3 minus 5, which is -2. And this means that a is equal to 1. Okay, so that's how to do that one. And this one, could do it in another way. So here I have x minus 5 over x minus 2 squared. So just take note, sometimes you can do it like this. You have x minus 5 over x minus 2 squared. This you can write as x minus 2 plus 3 over x minus 2. Yeah.
Can you check again? After you say x equals to 3, you say a plus -3.
Yeah.
Shouldn't you say 3a?
Where are you getting the 3 from?
You said x is equal to 3.
Where's
Yes.
the x here?
Sorry?
I substitute x here. Where else do you substitute the 3?
The other side of the equal sign. But shouldn't
Yeah.
it be 3a?
3a. Why 3a?
Oh, never mind that.
Okay. So this one, like I was saying, I can write it as x minus 2. This is squared over x minus 2 squared, and then plus 3 over, sorry, not plus 3. This is minus 3. Minus x minus 2 squared, and then here I have 1 over x minus 2 minus 3 over x minus 2 squared. Okay, so this is a shorter way of decomposing it into its partial fractions, which is not always possible, but you can do it like that. Instead of let x equal to this, let x equal to that, and then solve it. So here you can see I have a over x minus 2, 1 over x minus 2, and then minus 3 over x minus 2 squared. Okay, but that's confusing. Do it this way. So now that I have my a and my b, I can rewrite this integral. So what I'm integrating is x plus 1 plus 1 over x minus 2 minus 3 over x minus 2 squared dx. Okay, and now all these terms are pretty easy to integrate. This is x squared over 2, then I have x, then the integral of this is ln of x minus 2, and then here the derivative of the denominator is just 1, so I can add 1 to this exponent and then divide by minus 1 here. So I have plus 3 over x minus 2. It doesn't have to be in brackets. So because I'm dividing by negative 1, this negative changes to positive. And then plus my constant of integration. Okay, so that is how to use partial fractions when your numerator has a higher degree than the denominator. Okay, then we can do one more like that, number 20. We have to integrate x to the power of 4 minus x to the power of 3 minus 3x squared minus 2x plus 1 over x to the power of 3 plus x squared minus 2x dx. So remember, when the degree of the denominator is less than the degree of the numerator, you must use long division until what you have in the numerator is a degree less than what is in the denominator. Using long division, x to the power of 4, x to the power of 3, x squared minus 2x plus 1, x to the power of 4 divided by x to the power of 3 is x, and then we multiply, get x to the power of 4, and x squared times x is x to the power of 3, then minus 2x times x, this is minus 2x squared, then we subtract, this gives 0 here, minus 1 minus 1 is minus 2, x to the power of 3, and then minus 3 minus negative 2, that is negative 1. So we have minus x squared, and then the other two terms just come down. Then here the degree is not less than that one, so we must continue again. You only stop when the degree you have here, excuse me, when the degree you have here is less than what you have over there. Okay, so negative 2x cubed divided by x cubed, this is negative 2. And then we multiply negative 2 times x to the power of 3, that's negative 2x to the power of 3, and then negative 2 times x squared is minus 2x squared, negative 2 times negative 2x is positive 4x, and then we subtract, this gives 0, negative 1 minus negative 2 is positive 1, and then negative 2 minus 4 is negative 6, and this one just comes down. Okay, so don't write that plus 1. Okay, so now we can rewrite this from what we have in our long division. So what we're actually integrating is the integral of x minus 2 plus x squared minus 6x plus 1 over x to the power of 3 plus x squared minus 2x dx. So next thing is denominator. We have to factorize it. We can see that x is a common factor. So my numerator, this fraction here, I'll decompose it here. So this is x squared minus 6x plus 1 over x. Then just go ahead and factorize it all. Get x plus 2, x minus 1, like that. And we rewrite this as a over x, b over x plus 2, and then c over x minus 1. Okay, then combining these fractions, we have a multiplied by x plus 2 and x minus 1, then b multiplying by x and then x minus 1, c multiplying by x and x plus 2, and this must all be equal to x squared minus 6x plus 1. So because all the factors are different, then we can pick values of x to substitute in, and that will get rid of the other terms. So we start with x equal to negative 2. So when x is equal to negative 2, that's our first one. This one will be 0. That one will be 0. And then we have b times minus 2. And then minus 2 minus 1 is minus 3. And then on the other side, minus 2 squared minus 6 times minus 2 plus 1. That gives us 17. Okay, and this means that b is equal to 17 over 6. Then we can substitute x is equal to 1. So if x is equal to 1, this one is 0, this one is 0, and then we're left with c times 1 times 3. And then on the other side, you have 1 squared minus 6 times 1 plus 1. And that gives us -4. Okay, and then this means that c is equal to -4 over 3. Then the last one, when x is equal to 0. Okay, so if x is 0, this is 0, that is 0. And then we have a times 2 times -1 is equal to 1. And this means that a is equal to -1/2. Okay, so now we have our a, b, and c that we will put over there, and our integral then becomes the integral of x minus 2 minus 1/2 over x plus 17 over 6 over x plus 2 minus 4 over 3 over x minus 1 dx. Then we can integrate all of these without any problems. The integral of x is x squared over 2. The integral of -2 is -2x. And here the half can go outside. So this is -1/2 ln of x. And then here the 17 over 6 can go outside. So we have plus 17 over 6 ln of x plus 2. And then the last one is -4 over 3 ln of x minus 1. And then we add our constant of integration. So the only thing with this partial fractions is you have to do the algebra correctly, because if any of your a, b, and c are wrong, then obviously the answers that follow after that are also going to be wrong. Then number 2. The integral of 4x plus 3 over 4x cubed plus 8x squared plus 3x dx. So with this one, our denominator has a higher degree than the numerator. So the only thing to do is to factorize it. So x is a common factor, so you can take the x out and then factorize the quadratic equation that you have left. So what we have is 4x plus 3 over x, 2x plus 1, and then 2x plus 3 when you factorize it. Then we break this down, a over x, b over 2x plus 1, and c over 2x plus 3. Then our numerator will be a, 2x plus 1, 2x plus 3, plus b times x, and this is 2x plus 3, and c times x and 2x plus 1. This should be equal to 4x plus 3. Okay, so because all the factors are different, we can substitute some values of x. So we start with x equal to 0. So if x is 0, then this term is 0, this one is 0, and we are left with a times 1 times 3 is equal to 3. So this means that a is equal to 1. And when x is equal to negative a half, this is 0, and that is 0. So we have b times negative a half, and then 2 times negative a half is minus 1. Minus 1 plus 3 is 2. And then on the other side, 4 times minus half is 2. 2 plus, negative 2, sorry, negative 2 plus 1 is negative 1. Negative 2 plus 3 is positive 1. Okay, yeah. And then this means that b is equal to, this is negative 1, so b is equal to negative 1. And then x is equal to negative 3 over 2. If x is equal to negative 3 over 2, then this term is 0, that one is 0, and we're left with this one. So we have c times negative 3 over 2, and then 2 times negative 3 over 2 is negative 3. Negative 3 plus 1 is negative 2. And on the other side, we have 4 times negative 3 over 2, that is negative 6 plus 3, which is negative 3. And then this means that c, so here negative and negative, that gives us positive. So we have positive 3 is equal to 3c is equal to negative 3, so that means c is equal to minus 1. Okay, so we have our a, b, and c just substituted into the integral. So what we are now integrating, okay, so what we're integrating is a over x, so it's 1 over x, and then minus b over 2x plus 1, and then minus 1 over 2x plus 3 dx. Okay, so again, these are very simple to integrate. So the integral of 1 over x is ln of x. The integral of this is minus a half ln of 2x plus 1. And the last one is also minus a half ln of 2x plus 3, and then we add our constant of integration. Number 9, of dx over x plus 3, x squared minus x minus 2. So here this is factorized but not fully. So check if it's possible to factorize this, then go ahead. Otherwise, you would look at this as a quadratic term that is irreducible. So, but this one, it is possible to factorize it. So we have the integral of dx over x plus 3 x minus 2 x plus 1. And then when we break this down, we have a over x plus 3, b over x minus 2, and then c over x plus 1. And combining the numerators, we have a x minus 2, x plus 1, b x plus 3, x plus 1, c x plus 3, x minus 2, and this is equal to 1. So again, here all the factors are different, so I need 3 x values to substitute and then solve for a, b, and c. So we have x is equal to 2. So if x is equal to 2, this is 0, that is 0. And then we have b times 5 times 3 is equal to 1. On the right hand side, there's no x, so the answer on the right hand side is always equal to 1. And this means that b is equal to 1 over 15. Then we can have x is equal to minus 1. So if x is equal to minus 1, this is 0, that is 0. And here we have c times 2. And this is minus 3. And again, this is equal to 1, which means that b is equal to, not b, c is equal to minus 1 over 6. Then lastly, we can have x is equal to minus 3. So if x is equal to minus 3, then this is 0 and that is 0. And we have a minus 5 and minus 2 is equal to 1, which means that a is equal to 1 over 10. So now that we have our a, b, and c, we would substitute them there and then integrate. We are integrating a over x plus 3, so I have 1 over 10 over x plus 3. Then b over x plus 2, so that's 1 over 15 over x minus 2. And then c, which is minus 1 over 6 over x plus 1 dx. So this is 1 over 10 ln of x plus 3 plus 1 over 15 ln of x minus 2, then minus 1 over 6 ln of x plus 1, and then add your constant of integration. Okay, number 4. Integral of dx over x x plus 1 squared. So here we have linear factors, they are repeated. So this 1 over x plus 1 squared, we say this is just 1 over x plus b over x plus 1, and then c over x plus 1 squared. So you always build up until you get to the exponent over there. So if this was 5, then I would have d over x plus 1 to the power of 3, then the power of 4, power of 5, and then I would proceed. Right, I have one here like that. Okay, so now I need to work out my a, b, and c. So a I have to multiply it by x plus 1 squared, and b, I need to multiply it by x plus 1, and c just multiplied by x. This should be equal to 1. Okay, then we can do some substitution. Let's start with x equal to 0. So if x is equal to 0, then this and that one are 0. So I have a times 1, which is just a is equal to 1. And then I can have x is equal to minus 1. So if x is equal to minus 1, then this is 0, that is 0. Then I have c times minus 1 is equal to 1, and this means that c is equal to minus 1. Okay, and then to solve for b, you can pick any other number that you want to, it doesn't really matter. So I chose x is equal to 1. So if x is equal to 1, then I have a, which is 1. So I have 1 times 1 plus 1 squared, and then b times 1 plus 1, which is just 2. And c, we say it is minus 1, so I have minus 1 multiplied by x, which is 1, and then on the other side I have 1. So here I have 2b is equal to, this is 2 squared, this is 4, so I have 4 minus 2, which is 2. Sorry, 4 minus 1 is 3, and then I take it to the other side. I have 1 minus 3, which is minus 2. And then this means that b is equal to minus 1. So now that I have my a, b, and c, I can rewrite my integral. So I have a over x, a is 1, so I have 1 over x, and then b over x plus 1, so that's minus 1 over x plus 1, and then c, which is minus 1 over x plus 1 squared dx. So integrate this, ln of x minus ln of x plus 1, and then here we have plus 1 over x plus 1 plus c. Okay, and that's it. So with the other questions in the exercise, go and try them, and we will continue tomorrow.